Hello everyone. I've uploaded more than 600 videos to YouTube, and the range of topics I've been covering is quite huge, which probably results in the subscribers base being quite motley. But nevertheless, I had lots of fun doing those videos. And now, what am I trying to do? Well, I'm trying to make a sort of a research to figure out like how in particular the certain video topic and the programming language being involved in order to cover that topic, and maybe some miscellaneous keywords are likely to affect the eventual number of views that a certain video I've uploaded to YouTube is about to get. Okay, guys, so in the current working directory, I have the dataset called CMK Videos, which stands for Code Monkey King Videos. So I'm Code Monkey King, my videos are here. And you will be able to download this dataset from my GitHub. I'll give you a link in the description down below the video. So let's start by exploring the data set. So I'm using the CSV, which is the shell script to use the standard Linux commands to nicely pretty bring the CSV to the terminal. Right, so we have the following columns of features here. So the title, then we have the views, number of views this video has got so far, how many days it passed since the video has been published, and the duration of the video. So with these parameters, we'll be creating some new features, but yeah, this is all about to be covered. So these are all the videos I have, so it's slightly more than 600 overall. So to give you the exact number of how many we have here, so I can say cat minus n and cmk videos, 692 videos overall. Well, okay, now that being said, without further ado, let's actually start writing some code. So I want to create the file called train.py. And within this file, well, our first thing to do, want to import a few packages here. So I want to import regular expressions, which is the standard one. And we are supposed to be using regular expressions to search for programming languages and topics within the video titles. Then I want to import joblib. So this is the scikit-learn related module that allows you to store the module to the hard drive so that you can later load this and make predictions with. Then I want to say import pandas as PD. Pandas is going to be used for manipulating the dataset and altering the dataset the way so that it's used the particular machine learning algorithm we're supposed to be using, which is Decision Tree Classifier. Then from sklearn dot modal selection, I want to import train test split. So the idea is that in order to avoid what is known as overfitting, want to split the data into two tests, into the train and test sets. From sklearn dot tree, I want to import Decision Tree Classifier. So this is the algorithm we're supposed to be applying. And I will say a few words like why exactly this algorithm is in particular going to be used. And finally, to measure the accuracy of the model, I need to import accuracy score. So to do this, just say from sklearn.metrics import accuracy score. Now, in order to make it work, probably would rather create the virtual environment here rather than using the global modules, because that's generally considered to be a better practice. So I just say virtual environment, and I want to create the venv virtual environment folder here. You can skip this sort of a step. This is not essential, but I just prefer doing things this way. So now to activate this, I can say source venv bin and activate. And now would be installing modules we need. So I want to install pandas. Okay. And also install scikit-learn. And that should be fairly enough. Okay, now let's try to run Python 3 train py. Okay, no errors, which means that everything has been imported properly. Okay, let's go back to our train.py file. And now want to load data from CSV file. So we'll use the file I've just demonstrated. So I can say data equals to pd dot read CSV, and here are cmk videos.csv. Okay, and also want to let's print the data, and again Python 3 train.py. So here we see the data, but here is the problem. The idea behind the decision tree classifier is the following. So it treats the features as the categories, and based on those input categories were given to the algorithm, it sort of predicts how likely the output category is about to be reached using the set of input categories. So this means that we cannot use the textual data to represent categories. And also, we have the views as non-textual data, but actually this is like the integers. But there is also a problem. So since we're not predicting the number of views the video is supposed to get in some amount of time, but whether it's about to be above 1,000 or below, this means that the regression problem turns into the classification problem. And when I just started this, I was trying first to predict like not whether the video gets more than 1,000 views, but whether it gets like less than 100 views, less than 500 views, less than 1,000, less than 5,000, less than 10,000 views. But having that variety for the target feature, we are predicting the accuracy dramatically drops. So that's not an option. But when we try to predict exactly the binary outcome, like whether it's about to be higher than 1,000 views or lower, in that case, the accuracy turns to be quite pretty okay. Also, yes, the number of days that has been published, you see this days ago, years ago, so we need to turn the years, the months, and the weeks into the days. So those would be used as category itself. We're not supposed to be using length because it just probably adds some random noise to the model. So when I try to involve the length as well, the overall accuracy drops. So I'm not going to be be using that here. And as for the title, we'll pick a few video topics most common to my channel in particular, and those programming languages that has been involved. And we'll encode the topics as like topic like Linux would be like 1, web scraping would be like 2, text editors 3, etc., etc. And also the programming languages would be encoded in a similar way. So let's say Python is 1, JavaScript 2, C 4, C++ 5, Golang 6, and assembly like 7, and so on. So that eventually we would only have the categorical data within the features to fit the certain algorithm we're supposed to be using. So now we need to make what is known as like preparing the data set to make sure that it fits the algorithm we're supposed to be running. And in order to do this, let's write some helper functions first. So I'm going back to my train.py file, and here, so we will start by extracting programming languages. So I can say get programming language, and here let's define a function called get lang. It would be taking pandas data frame series row as an input, so that's quite important. And here we define the counter that is equal to 0, and then we just loop for language in the list of the programming languages. And here I'm using the regular expressions already to match the certain programming language. So we'll start by Python, and /b stands for black. So just to give an idea for blank, just to give an idea like what would be matched in particular. So let's say I have like something that then Python and something else. So Python would be matched in this case, but Python would not be matched in this case. Okay, and also if there would be like colon after Python or comma or whatever, this would also match Python as a programming language, just to give an idea. And let's just populate this a little bit. So after Python, let's do JavaScript. Then let's do JS. So sometimes I use JS. So we'll treat JavaScript and JS as the single category, because essentially those two are the single programming language. So hopefully that makes sense. Then want to have C++, but since plus is treated to be like the regular expression special character, so I just escape pluses there. Okay, and also I have Golang recently being added as the weapon of choice programming language, one of the programming languages I start using quite extensively, and also Go. And finally, last but not least, is assembly. I was doing quite a lot in 6502 assembly, in x86 assembly as well. Okay, so within this list, want to do the following thing. All right. So first thing I want to increment the counter, and then I do the regular expression search. So I can say if regular expressions dot search, searching for a lang within the row, which is the pandas data frame series row, then title, and want to make it lower, because I can have like camel case, uppercase, lowercase, whatever case values there. So if it finds, if it matches something, in this case, well, generally I want to return the index, but it might be that if it finds the JS in lang, then I want to return the index of 2, which is JavaScript. Okay, and also the same for Golang. I say elif and Golang in lang. I want to return the index of 6. All right. Otherwise, I just want to return whatever index value is, right? And it might also happen that neither of programming languages listed above is being involved within the video title. In this case, I want to return 8. So that's the length of the list plus 1, so return 8. So just a different value than those programming languages we have there. All right, so hopefully that makes sense. Let's still make sure that it sort of runs, no errors. Okay, we can already do some feature engineering here. So let's say feature engineering here. So I want to say that I'll create a new feature called lang, and this is going to be equal to data.apply, and I want to apply this get lang, and by default this would send the certain row of the dataset. I said dataset series row. Well, it's probably more accurate way to say is data frame row, not the data frame series, because series is just a column essentially. Yeah. And also want to say axis equals to 1. Okay. And let's just print the data again after. So let's have a look. Okay, so now we have the language being specified. So we say like 8 means nothing. Then the second one, building Linux distro from scratch, and they're compiling Golang. You don't see this, but it is that. Hence, the lang is equal to 6. Right. So we'll create the CSV file out of the altered dataset that we have in here to see all the changes. But for now, you see like the new series has been added, which is the lang. Okay, and here, and the next thing is to add the topic, so which is quite similar to what we've done with the get lang. So I can just probably copy, so 12 to 29, copy to after 30. Okay, so here we want to get video topic. Okay. Here I want to say for topic. All right. And we have quite an extensive list here. So first, whatever has the scrap. So this might be scrapey, web scraping, or whatever related to scraping, because unfortunately that's the biggest topic on the channel, although I'm sick and tired of that. But anyway, can do nothing to this. Then we have beautiful soup, which would also be treated as scraping because that's the library for HTML parsing using for web scraping. Then we have web related things. So this might be again web scraping, but web development as well. So web is treated to be like a different part here. Then we have the I've been doing raycasting, believe it or not. So raycasting. Then I've been doing lots of Linux tutorials, Linux related tutorials, like building your own Linux distribution from scratch, compiling Linux kernel, things like that. So we have Linux. Then I was doing lots of text editors. So like how to make your own text editor from scratch, for instance. Then I was doing retro computing related stuff. So Key1 emulators, lots of Key1 emulators in JavaScript, in C, Key1 emulator for Arduino as well. So yeah. And let's add some more. What else have I been doing so far? Yes, so let's do Arduino. All right, that's another topic. I was doing OpenCV. So OpenCV. Okay. And also I was doing so here I'm not going to be using these /b stuff. I just say convert, because this might be converting like from one format to another, and so on, and have quite great views where the video is about converting one format to another. So it's a little bit different selector here. And finally, last but not least, is the 6502. So if I do something in 6502 assembly, well, although this 6502 is assembly, it's not a topic, but for the sake of modal accuracy, I actually keep it here, because it just works better overall. All right, now the same thing here, but yeah, also searching within the title. But in this case, we want to say if we have the soup, which is most likely beautiful soup, in not the lang but the topic. In this case, we want to return 1 because that's essentially the same as web scraping. Okay, and also if we have Flask in topic, I want to return the index of 4. Otherwise, I want to return I, and the overall number of the length of topics plus 1 is going to be equal to 13, right? And yes. So now we can add one more feature. So here I can say data and topic and equals data.apply, and I want to use the get topic and along the axis 1. Okay, let me quickly check whether I have renamed. No, I haven't renamed this one. So get topic, right? Quit. Now if I did everything properly, it should add one more. Okay, nameline is not defined. Line 48. Let's have a look. Line 48. Yeah, of course. Not the lang, but the topic. So I'm using topic here. Train the Py. Yeah, now we also have the topic. So you select topic 5, that regards to Linux. Topic 13 regards to like some random stuff I've been doing a lot on the channel. Yeah, again, like we'll see the resulting data set just in a few moments. And yeah, now for now, let's just drop back. And another quite important thing that actually helps us to improve the overall accuracy is to pick some random keywords. But for now, I'm not going to be doing this because I just really want to show how adding new features might positively impact the accuracy of the model. So for now, I would just leave these like features like topic and the programming language alone. And now it's time to deal with views because that's the prediction target for our model. So I can say like categorize views, and here I want to create a function. I call it is worth because it's about to answer whether it's worth. So again, row data frame row here as an input. It's intended to answer the question whether it's worth time and effort, basically. So simply, if I say if row indexed by views is less than 1000, in this case, I just return 0. So it means like it's not worth it. And otherwise, just want to return 1, right? So let's add this as well. Let's probably just quickly copy paste things. So here I want to use the is worth, and this is going to be let's call it worth. So this is our prediction target. We can also call it target, but yeah, just know that this is the target column, whether it's worth or not. Okay, so let's quickly check whether it still works. Yeah, so those videos having less than 1,000 views are marked with zeros, which means like it doesn't worth doing those. Although that's not essentially the truth, but just for the sake of didactic purposes behind this tutorial, yeah, we'll keep things as is. And also, last but not least thing to deal with is want to convert year, month, weeks to days. So def, let's say get days, and again takes the row. So how to pass the days? The days is going to be equal, so I want to convert things to integer, and we're taking row published, so that's the column containing days, and I want to split these by the empty space and to get the first value, which is how much either days or years or weeks or months has passed. And now based on this, we can do another interesting decision making here. So we can say if year in row published, in this case, want to return days multiplied by 365, so the number of days in a year on Earth in solar system. Okay, elif month in row published. Yeah, it's probably published. I can copy paste things here as well. Want to return days multiplied by 30. Well, not always 30, but generally there is 30. So else if we have the week, right? Then multiply by 7 respectively. So hopefully this makes sense and is indeed quite self-explanatory. And otherwise, what we want to do, say else, just return days as is, because that essentially like how many days the videos has been uploaded. Yeah. So, and also let's add the days here. So this, let's just put these before the worth. So I can say data. Let's just let's copy paste things. Yeah, here I say days, and I want to get days here, right? And yeah, let's try to run this to see. Okay, it wasn't closed. Okay. All right. Okay, another typo. Else. Yeah, great. Now we also have the day. So instead there's 1,460. Well, I guess that's 4 years. All right. So we have the days being properly passed now as well. And already, believe it or not, this is already enough to have at least some result for our Moses. So let's get to the most interesting part. All right, so train, and now want to filter the data set because we don't quite need to have the initial title views, etc. So filter data set. And we're not even going to be dropping anything from dataset, but instead we can simply say data equals to data and just specify those features we want. So we want to have the length want to have the topic, want to have days, right? And we also want to have the target column, which is whether it's worth to make such a video or not, whether it was worth or not. Okay, and right, quit. And now already we have the data set consisting of only numbers. Now to have a better understanding of what's going on here, let's export this temporarily to the CSV file. So I can say data.toCSV and let's say filtered.csv and run. And now I can say CSV and have a look at the filtered data. All right, so this is what we got here. So we got, well, don't pay attention to the numbers. It's not really that essential. However, it's good because we now see how much videos we have overall. Hopefully that makes sense. So you see like topics and just use page up, page down, it's faster. So len topic. So the programming language is encoded from 1 to 8. Topic is encoded from 1 to 13. Days are left as is, but also treated to be as a categorical feature. And whether it's worth or not is represented by either 0 or 1. Okay, so we have some ones, because those zeros are those videos that didn't yet reach 1,000 views, probably would never ever reach that amount. So mostly, yeah, videos mostly suck, but some do reach like above the 1,000 views. We don't know how much. This might be like 1,001 view, 5,000 views, or 10,000, or even the maximum number for my video for one of my videos is 28,000 views, I believe. The number of days is growing because like this is like 3 years, I guess. This is like, oh, maybe 2 years. 2 years. This is likely to be 3 years, and the latest, the earliest videos are like 4 years ago, I guess. This 1,460. So this data is now already good enough to be used for the Decision Tree Classifier algorithm to be applied over this data. So without further ado, let's actually go and apply the algorithm. So if I do, no. If I do go back, right, then here, next thing we want to split the data, say split data into input features, and this is the conventional name for that is X, and target variable, which conventionally should be Y, like this. And yeah, that's the commentary, obviously. And I can say X equals to data dot drop, and I want to drop the worth column, and X is equals to 1, and the target variable Y equals to data, and what we're supposed to be predicting is whether it's worth or not to make such a video. So these two lines are absolutely essential. So we use the len, the topic, and the days to predict whether it's worth or not. So that's generally what these two lines of code are all about. So X are len and topic and the days, and Y is worth. Just to show you this, I can print X, and I can also print Y, right? Quit, and let's have a look. Yes, just a typo. Yeah, just a typo. drop. Okay, so here we go, and the upper data set is our input features. The lower data set is the target variable. So hopefully this makes sense. Okay. Now, the next absolutely essential thing to do is to split data into training and testing sets. Training and testing sets. Now, why is this needed, you might be wondering? So the idea is that if the model only trains on the data it has seen already, it might start suffering from overfitting, which means like it performs extremely well on the known data, but when it faces the unknown data, the results are miserable. So that's the problem of overfitting. So in order to avoid that sort of a scenario, we only use 80% of the data to train the model, while the rest 20% is going to be used as the test sets. And I define the X train and the X test and the Y train and the Y test equals to, and here we're using the function we've imported earlier, train test split, and x, y, test size x and y, those like input features and the target variable. Then the test size is going to be equal to 0.2. So again, like 80% for training, 20% for testing, and also want to randomize the data set. So, and we want that randomization be fixed all of the time. So I can say random state, and again, the conventional value is 42. Right? So, next thing to do, want to actually train the model. So train model. And like I've been mentioning earlier, the algorithm we're supposed to be using is random forest classifier. So I just create a model called classifier here, and this is going to be equal to Decision Tree Classifier. And I provide the only hyperparameter, which is the random state, equals to the conventional value of 42. That's the entire separate topic on how to improve the modal performance by specifying the hyperparameters. Like, for instance, you can say for the decision tree classifier, you can I just spotted a typo, classifier. You can specify the maximal depth, for instance, or how to perform the splits and many more parameters. But I've been playing around with those, but for this particular purpose, it really works nicely with the standard default configuration. So we are supposed to be relying indeed on the default configuration. And now to actually train, want to call the fit. And here we're using the X train as the training set, as well as the Y train, right? And the next thing to do is to actually use our model to predict the rest that we have the test plot, the 20% I've mentioned earlier. So predict and evaluate. So here I say y pred, and we say classifier dot predict and x test, those 20%, and I want the results to be integers, so I can add as type int like this. Okay, and now finally, last but not least, I want to measure modal accuracy, because we need to know how well the model actually performs. So let's do some pretty prints here. Yeah, great. So now we have the following thing. So you see, like, the most influential feature is the programming language according to this particular model that we've just trained. So it takes 0.39. Then days is second most important, 0.36, and topic is the least important, which only takes 0.24. But actually, topic is way more important than this particular model actually thinks. I want to classify miscellaneous keywords. And yeah, this will give quite a dramatic change, believe it or not. So let's say def get miscellaneous and row as the dataset row. So if we have how to in row title, this case, and just make sure to convert this to lowercase letters. In this case, we want to return category 1. Let's probably do some copy paste here. So elif, we have live coding. Now, interesting thing here is that with like playing around with the particular keywords I'm selecting, I may have some dramatic changes on the predicted accuracy. So that's one of the key techniques I've been using here to actually improve the accuracy, the overall accuracy of the model. And also, this is a little bit strange, but yeah, this also contributes a lot. So if I suggest search for scrap, again, like scraping, web scraping related stuff, because there is a whole lot of freaking web scraping on the channel, even though this has been already covered as the topic. But if I use this as the miscellaneous keyword as well, this also helps to dramatically improve the performance, the accuracy of the model. So here I want to return 3, and otherwise else I want to return 4. And here elif. Okay, and now also we need to add these to our features. So here I can say data. Just grab one like this. So if we have the miscellaneous, want to apply the get misc here, and when we are filtering the data set, also just after the topic, I want to add the miscellaneous thing here. Okay, and the rest is fairly the same, so I don't really want to convert the eventual data set to CSV. We don't quite need this anymore. So yeah, let's have a look. Okay, probably one last thing I want to do is under the train.py, I want to say I want to provide the, let's call it, so the main driver, and just say if name is equal to main. Only in this case we want to run the following code. The idea is very simple. I'm supposed to be importing functions to get the language topic and the miscellaneous keywords from this file, and if I don't do this, then it will be printing the accuracy stuff here, which we don't really want to. So from 102 and to the very last line, I want to substitute the new line like this. Right, quit, and Python 3 train py. So let's train this one last time. Yeah, we got the classifier, and now we can already we can create the file called predict.py. So what packages do we need? I want to import joblib, because we're supposed to be using the saved model, the scikit model we've just saved. Then I want to import pandas as PD because we need to encode user input as the pandas data frame to source it to the module itself. And then from train, which is our Python file, train.py, I want to import the functions getLang, getTopic, and getMiscellaneous. Great. Now next thing to do, want to load a pre-trained model, and module is going to be equal to joblib and classifier.pkl. And now let's create the function called predict results. Okay, predict result. So def predict result. It's going to be taking title as the only argument. And now here is how we're supposed to be doing things. So first we want to loop over the range of days, since we're supposed to be predicting like in how many days this is likely to gain 1,000 views. We need to iterate over the days. So hopefully that makes sense. I can simply say 4 days in range, and from 1 to 4 years, because that's the limitation. Like since my YouTube channel has started, it does nothing about what happens earlier than 4 years. Then we want to create a data set. So say data, just like this, data equals to pd data frame, and I want to create this like use the from dictionary, and here specify the dictionary containing the title and specifying the list. That's important, otherwise it's not going to work. Title like this. And yeah, next thing we want to encode features. Okay, and here we can say data and want to extract the programming languages, just the same steps we've been considering when we have been preparing data sets. So data.apply, and I'm using the getLang along the axis 1. Same thing for topic, same thing for misc, and for days we just want to get the days to turn this to the list. Before that, so here we use the get topic, here we use the get miscellaneous. After this we can predict results and just say y predict equals to model.predict and our data frame as the input. Now so we want to return success in case if y prediction 0, so that's the only prediction literally, is going to be equal to 1 to return whatever days it has taken to get the result. And otherwise I just want to say return failure, so return 0. All right, and then finally the main driver here. So this is going to be a simple loop, so just say while true. I want to get user input, and before that I just print enter your video title. and then title is going to be equal to input and prompt. Okay, so if title is equal to quit, then want to break out of the loop, escape conditioning, then days equals to predict result, and send in title as an argument. And finally, if days are greater than 0, we can say print your video is about to gain 1,000 views in, and specify the days itself. And otherwise, just want to print your video sucks, because it doesn't it's not about to obtain 1,000 views ever. Within 4 years it released. You should try something else. Okay, and if I did everything properly, in this case, it should now work. Right, quit. So let's try Python 3, predict.py, okay, valid syntax, which line number, 39, module is not callable, 1.7, yeah, we need to say joblib dot load here. Okay, enter your video title. So let's just type some gibberish just to make sure that, yeah, any other errors there. Unseen title, yeah, so we forgot to drop the title. So want to drop title, and here I say data equals to data dot drop, and want to drop the title. Axis 1. Okay, some gibberish. Okay. Is it 10? Okay, your video sucks, you should try something else, which is a reasonable response because I just input some gibberish, so it's not about to have 1,000 views ever. Okay. Yeah, just lagging for some reason. Okay, let's try again. Just clear everything and try to predict. So let's try to enter the title of this particular current video. So estimating when a video gets 1K views using Python and Scikit learn. Okay, it should gain 1,000 views in 198 days. Well, it's not really that much promising. I hope this happens faster. But anyway, we'll see how accurate this prediction is. So yeah, guys, this is from my side. I hope you enjoyed the tutorial, and feel free to play around with it. And you can also change the data that is relevant to whatever YouTube channel if you manage to download the data for that channel. By the way I've been achieving that was the following. Once I've written a Chrome browser extension called WebGrabber. Essentially what it does is scrolls down the infinite scroll page, if any. If there is no infinite scroll, it just scrolls down to the very bottom of the page, and then it extracts the dynamically rendered HTML from the browser and stores that as the HTML file. You can copy the content and store it manually to as the HTML file. And then you can use some web scraping technique like, say, Beautiful Soup HTML parser to extract the relevant information to obtain the dataset for a given YouTube channel videos. And then you can alter the encoded features, like this might not be programming videos and topics, it might be something else, like the keywords might be different. You may want to engineer more features, and then you can like play around with stuff and try to see how likely the prediction is going to be. Now, that's it from my side. Thanks for watching. See you later and cheers.